An astrolabe is an elaborate inclinometer, historically used by astronomers, navigators, and astrologers. Its many uses include locating and predicting the positions of the Sun, Moon, planets, and stars, determining local time given local latitude and vice versa, surveying, and triangulation. It was used in classical antiquity, the Islamic Golden Age, the European Middle Ages and Renaissance for all these purposes. In the Islamic world, it was also used to calculate the Qibla and to find the times for Salat prayers. There is often confusion between the astrolabe and the mariner's astrolabe. While the astrolabe could be useful for determining latitude on land, it was an awkward instrument for use on the heaving deck of a ship or in wind. The mariner's astrolabe was developed to solve these problems. Etymology. It gives the translation *startaker for the English word astrolabe and traces it through medieval Latin to the Greek word astrolabus from astron, star, and lambonin, to take. In the medieval Islamic world, the word astrolabe was given various etymologies. In Arabic texts, the word is translated as akhdh al-kawakib, which corresponds to an interpretation of the Greek word. Al-Biruni quotes and criticizes the medieval scientist Hamza al-Isfahani, who had stated, "Astrolabe is an Arabization of this Persian phrase." In medieval Islamic sources there is also a fictional and popular etymology of the words as lines of Lab. In this popular etymology, Lab is a certain son of Idris. This etymology is mentioned by a 10th century scientist named Al-Kami but rejected by Al-Khwarizmi. Lab in Arabic also means sun and black stony places. History. Ancient world. An early astrolabe was invented in the Hellenistic world by Apollonius of Perga around 220 BCE or in 150 BC and is often attributed to Hipparchus. A marriage of the planisphere and dioptra. The astrolabe was effectively an analog calculator capable of working out several different kinds of problems in spherical astronomy. Theon of Alexandria wrote a detailed treatise on the astrolabe, and Lewis argues that Ptolemy used an astrolabe to make the astronomical observations recorded in the Tetrabiblos. It is generally accepted that Greek astrologers, in either the 1st or 2nd centuries BC, invented the astrolabe, an instrument that measures the altitude of stars and planets above the horizon. Some historians attribute its invention to Hypatia, the daughter of the mathematician Theon Alexandrakis, and others note that Synesius, a student of Hypatia, credits her for the invention in his letters. Astrolabes continued in use in the Greek-speaking world throughout the Byzantine period. About 550 AD, the Christian philosopher John Philoponus wrote a treatise on the astrolabe in Greek, which is the earliest extant Greek treatise on the instrument. In addition, Severus Sabocht, a bishop who lived in Mesopotamia, also wrote a treatise on the astrolabe in Syriac in the mid-7th century. Severus Sabocht refers in the introduction of his treatise to the astrolabe as being made of brass, indicating that metal astrolabes were known in the Christian East well before they were developed in the Islamic world of the Latin West. Medieval-era astrolabes were further developed in the medieval Islamic world, where Muslim astronomers introduced angular scales to the astrolabe, adding circles indicating azimuths on the horizon. It was widely used throughout the Muslim world, chiefly as an aid to navigation and as a way of finding the Qibla, the direction of Mecca. The first person credited with building the astrolabe in the Islamic world is reportedly the 8th century mathematician Muhammad al-Fazari. The mathematical background was established by the Muslim astronomer Albertinius in his treatise Kitab Arizona Zij, which was translated into Latin by Plato Tiburtinus. The earliest surviving dated astrolabe is dated R315. In the Islamic world, astrolabes were used to find the times of sunrise and the rising of fixed stars, to help schedule morning prayers. In the 10th century, al-Sufi first described over 1,000 different uses of an astrolabe, in areas as diverse as astronomy, astrology, navigation, surveying, timekeeping, prayer, Salat, Qibla, etc. The spherical astrolabe, a variation of both the astrolabe and the armillary sphere, was invented during the Middle Ages by astronomers and inventors in the Islamic world. The earliest description of the spherical astrolabe dates back to al-Nayrizi. In the 12th century, Sharaf al-Din al-Tusi invented the linear astrolabe, sometimes called the staff of al-Tusi, which was a simple wooden rod with graduated markings but without sights. It was furnished with a plumb line and a double cord for making angular measurements and bore a perforated pointer. The first geared mechanical astrolabe was later invented by Abu Bakr of Isfahan in 1235. Peter of Maricourt, in the last half of the 13th century, also wrote a treatise on the construction and use of a universal astrolabe. Universal astrolabes can be found at the History of Science Museum in Oxford. The English author Geoffrey Chaucer compiled a treatise on the astrolabe for his son, mainly based on Messahala. The same source was translated by the French astronomer and astrologer Pellerin de Prusse and others. The first printed book on the astrolabe was Composition and Use of Astrolabe by Christian of Praga, also using Messahala, but relatively original. In 1370, the first Indian treatise on the astrolabe was written by the Jain astronomer Mahendra Suri. The first known metal astrolabe in Western Europe is the Destume's astrolabe made from brass in 10th century Spain. Metal astrolabes avoided the warping that large wooden astrolabes were prone to, allowing the construction of larger and therefore more accurate instruments. However, metal astrolabes were also heavier than wooden instruments of the same size, making it difficult to use them as navigational instruments. The astrolabe was almost certainly first brought north of the Pyrenees by Gerbert of Aurillac, where it was integrated into the quadrivium at the school in Reims, France, sometime before the turn of the 11th century. In the 15th century, the French instrument maker Jean Fusaris also started remaking and selling astrolabes in his shop in Paris, along with portable sundials and other popular scientific gadgets of the day. 13 of his astrolabes survive to this day. Finally, one more special example of craftsmanship in the early 15th century Europe is the astrolabe dated 1420, designed by Antonius de Pacento and made by Dominicus de Lanzano. In the 16th century, Johannes Stoffler published Elucidatio Fabricae Usus Astrolabii, a manual of the construction and use of the astrolabe. 4 identical 16th century astrolabes made by Georg Hartmann provide some of the earliest evidence for batch production by division of labor. Astrolabes and clocks. At first, mechanical astronomical clocks were influenced by the astrolabe. In many ways they could be seen as clockwork astrolabes designed to produce a continual display of the current position of the sun, stars, and planets. For example, Richard of Wallingford's clock consisted essentially of a star map rotating behind a fixed treaty, similar to that of an astrolabe. Many astronomical clocks, such as the famous clock at Prague, use an astrolabe-style display, adopting a stereographic projection of the ecliptic plane. In recent times, astrolabe watches have become a feature of oterology. For example, in 1985 Swiss watchmaker Dr. Ludwig Goexland designed and built an astrolabe wristwatch in conjunction with Ulysse Naden. Dutch watchmaker Christian van Erklaas, who also manufactures astrolabe watches today. Construction. An astrolabe consists of a disk, called the mater, which is deep enough to hold one or more flat plates called tympans, or climates. A tympan is made for a specific latitude and is engraved with a stereographic projection of circles denoting azimuth and altitude and representing the portion of the celestial sphere above the local horizon. The rim of the mater is typically graduated into hours of time, degrees of arc, or both. Above the mater and tympan, the rete, a framework bearing a projection of the ecliptic plane and several pointers indicating the positions of the brightest stars, is free to rotate. These pointers are often just simple points, but depending on the skill of the craftsman can be very elaborate and artistic. There are examples of astrolabes with artistic pointers in the shape of balls, stars, snakes, hands, dogs' heads, and leaves, among others. Some astrolabes have an arrow rule or a label which rotates over the rete and may be marked with a scale of declinations. The rete, representing the sky, functions as a star chart. When it is rotated, the stars and the ecliptic move over the projection of the coordinates on the tympan. One complete rotation corresponds to the passage of a day. The astrolabe is therefore a predecessor of the modern planisphere. On the back of the mater there is often engraved a number of scales that are useful in the astrolabe's various applications. These vary from designer to designer, but might include curves for time conversions, a calendar for converting the day of the month to the sun's position on the ecliptic, trigonometric scales, and a graduation of 360 degrees around the back edge. The alidade is attached to the back face. An alidade can be seen in the lower right illustration of the Persian astrolabe above. When the astrolabe is held vertically, the alidade can be rotated and the sun or a star sighted along its length, so that its altitude in degrees can be read from the graduated edge of the astrolabe. Hence the word's Greek roots. Astron equals star plus lab equals to take.